Hey, I thought we would do another integral today, and we'll do it on the digital blackboard today. We have the integral from 0 to 1, x to the 19th, 1 minus x to the 5th cubed dx. Okay, a few things. Now, in theory, we could multiply this thing out, and then we would just be doing the power rule. I kind of want to avoid that. That's kind of a tedious method. I wanted to do something different. And what I wanted to notice was the similarity here to the beta function. And let's just look real quick what the beta function looks like. So over here on the right, we've got our beta function. Okay, and notice the similarity here where we have the exponent on the x and the exponent here. And then once we have this, it's pretty easy because then we can just find the solution in terms of the gamma function here. And the gamma function, if we have like integer exponents, we can just use factorials and get to a solution pretty quick. The one problem with this problem that I find really interesting is just this exponent here that we need to deal with. That exponent's the real trick. Otherwise, we could basically start jumping right to our answer. So let's see if we can deal with this. Okay, so if the whole issue is this exponent, then let's try to deal with that with a u substitution. So what I'm going to do is I'm going to call my x to the 5th equal to u. Okay, and that way I'm going to get it, hopefully more into this form of the beta function that we want. And let's take our derivative. So for du, we're going to have 5 x to the 4th dx. Now let's just solve for dx so that we can get it all ready to go. So we're going to have du over 5x to the 4th. Then let's make this substitution. So let's see what's going to happen. For our bounds, we plug a 1 in here, and we're going to have just a 1. And we plug a 0, and we have 0. Now from our dx term, I'm just going to pull this out as a 1/5. Okay, that's just going to be a constant. We'll pull that out front. For now, I'm going to keep my x to the 19th. We're going to have to simplify this. We can't have x in, we're dealing with u now, so we can't really have x, but we're just going to keep it there temporarily. We're going to have 1 minus u cubed du. Okay, but this thing here, when we divide x to the 4th and x to the 19th, we're going to get x to the 15th. And so x to the 15th, you'll just notice if we cubed our u cubed is x to the 15th. I'm just going to do a quick rewrite and get it all into u. Okay, so now after the rewrite, we have our integral here all in u. And you'll notice it's actually perfectly, now it's set up as we got to just, on the u here, we just have a 1 as the exponent. So we're in the exact right form to use our beta function here. You'll notice that the exponent's 3. This can be written as 4 minus 1. Okay, 4 minus 1. So our z1, using this form here, so our z1 format, our z1 is actually going to be just 4. And then our z2 is also going to be 4, 4 minus 1 being 3. Okay, and then in the denominator, we're looking for the gamma of 4 plus 4, which is just 8, using this formula over here. And then the one thing we don't want to forget, we have this 1/5 up front, so we're going to have 1/5 of this whole thing in our solution. So to calculate this, we can just turn this into factorials. We have integer values, we can just use factorials. We know that just if we have the gamma of n, let's say, that's going to be the same thing as n minus 1 factorial. So then let's just get our solution, or get this into a fraction. So gamma of 4 is going to be 3 factorial. Gamma of 4 is going to be 3 factorial again. And gamma 8 is going to be 7 factorial. And with this, I'm just going to do some canceling here. I could leave it like this, but I think we're just going to simplify this a little bit. So what I'm going to do, let's see, if I can write my 7 factorial as 7 times 6 times 5 times 4 times 3 factorial. I'm going to take one of these okay, we'll have 1 3 factorial over here. The other 3 factorial I'm going to write as 6. 3 factorial is 3 times 2 times 1. Then I can cancel these 3 factorials here. I can cancel a 6 here. Then I think we're left to just multiply this thing out. 25 times 4 is 100, times 7 is 700. And that's going to be our solution. I was playing around with some of these, and they come up with a pretty satisfying answer, because a lot of them end up looking like that, 1 over 700. So anyway, fun problem. Thanks everyone for watching. Have a good day.